Alright, so this lesson is titled Solving a System of 3 Equations Using 3 Variables. So it's very similar to our previous lesson where we had 2 equations using normally x and y, but now we're going to have 3 different variables, normally x, y, and z. So you're just going to have to take what you've already learned and extend it to just another dimension. You can use this either by substitution or elimination. However, since most of you like elimination, I'm only going to teach the elimination method. Elimination in this kind of problem is much easier. So when I give you my equations, let me give you an example of one real quick. Here's the example. So I want you to notice that we have x, y, and z in all 3 equations. And your goal is to solve the correct one answer only for x, y, and z so that it will work in all 3 equations. So if I just gave you a random answer over here, and I say, will this work? Well, let's go ahead and check it. We got to plug it into all 3, and if it works for all 3, then our final answer is yes. If at any point it doesn't work for any one of these individual equations, then you just say no to the whole thing. So we're going to go 2 times my x is 1, plus my y is 0, plus my z, which is negative 1. And will I get 3? Well, that will give me 2 plus 0 plus negative 1. That will give me 1. So immediately it doesn't work for the first one. So if it doesn't work for this one, then I just say no to the whole problem. And I don't even have to bother checking the second or third. If this was a yes, then you would go on to this one and check this one. If that was a yes, then you go on and do this one. And then if this was a yes, if all 3 were, then you would say yes. So we're going to talk about how to solve a system. It says using any 2 of the 3 equations, we're going to eliminate a variable. So you're going to be able to pick which variable you want. So just like our previous notes, I said decide on a variable. I don't care if you want to look at the x's or the y's or the z's. You just decide, just pick one, and you're going to deal with that throughout the whole problem. So let's go ahead and do step 1 on our next problem. So I want you to look at all the x's here, all the y's, and all the z's. Okay? Just pick something. It doesn't matter what you want to focus on. So let's just say that I want to focus on the z's, and so I'm going to look at the first 2. So I'm going to focus on the top 2 equations. I'm going to pick these 2. And I'm going to go here and label it step 1. I'm going to work with 2x plus y plus z equals 3. And then 3x plus 2y minus z equals 2. And again, I focused on the z's. And the reason I focused on the z's right off the bat is I noticed I don't have to do any other work to start with. They're already opposites right now. So I can go ahead and start adding straight up and down. Straight up and down, remember that's a 1. And then these will eliminate. And straight up and down, if I add, I'll get 5. So what I've done is I've taken my longer equation that has 3 variables, and I've cut it down to 2 variables, x and y, like you're used to. Now this second step is the crucial part. It says now using a different pair of the 3. It means you can't use the first and second one again because you just did that. Pick different pair. A pair means 2. But you have to eliminate the same exact variable. And that's where you run into trouble if you don't follow my directions. If you try to eliminate x now, you're going to find out that you have nowhere to go. You have to get rid of the exact same variable you just got rid of. So step 2, I'm going to go ahead and use these ones. So 3x plus 2y minus z equals 2. Negative x plus 3y plus 2z equals 1. I'm going to focus on the z's because that's what I got rid of last time. But I can't just add these up together right now like I did over here because these will not eliminate. So what I'm going to have to do is I'm going to have to multiply this top by something so that I can eliminate with the positive 2. So I'm going to have to multiply the top by 2. And I'm just going to arrow over what happens when I go ahead and distribute by 2 here. Everything. I'm going to get now 6x plus 4y minus 2z equals 4. Remember to distribute that number out front to all the things here, all the terms. The bottom one I didn't have to do anything with, so I'm just going to rewrite it. So now that I have it set up for elimination, now I can actually add. So if I add these together, I'll get 5x. If I add those together, I will get 7y. These cancel. Add those together, I'll get 5. So step 1 and 2 are done. Step 1 and 2 are basically just to get it ready to be done. So step 3, once you get to step 3 properly, then you should be home free, because it says using the 2 new equations, solve for the 2 variables normally. So this is now what you did back in the previous lesson with elimination or substitution. So now it should look like a normal problem, mainly with x and y. So now step 3 says take the 2 equations you just ended up with up there, 5x plus 3y equals 5, and 5x plus 7y equals 5. And we're going to solve these as if it's a brand new problem. So if I look at these, I'm going to do elimination again. I'm going to try and eliminate the x's, but I can't add right now because these are going to give me 0. They're going to give me 10. So what we did in the past is we multiplied everything by -1. Just one equation. So if I go ahead and distribute here, I will get -5x minus 7y is equal to -5. Now I can add straight up and down. These are eliminated. If you add my y's together, you should get -4y, and add those together, you should get 0. Keep solving for y. We would divide by the number that's being multiplied. And as soon as you get one answer, remember we immediately went back and plugged it in. So I don't care if you pick this one or this one or this one and this one. We'll plug them back into something of the green, the step 3 method here. So 5x plus 3 times your y is 0, equals 5. So 5x plus 0 equals 5. We don't need that. So 5x equals 5, and x will equal 1. So in the previous lesson, just this green part would be a problem, but this is really in the middle of this bigger problem. So we have x and we have y. The only thing we don't have is your third variable, your z. That's where we go back and do step 4. Step 4 says substitute the values, and also that's plural, that's the 2 answers you just got, back into any of the original, way back at the beginning, and get your final third variable. So pick one of these originals up here. Let's just pick the top one. 2x plus y plus z is equal to 3. So it means 2 times your x value, your x is 1, plus your y answer, which is 0, plus your z, which will give you 3. So that's 2 plus 0 plus z, which is 2 plus z. So solve for z, and you should have gotten z to be 1. Now you want to write your final answer. It always goes in alphabetical order. So our x is 1, our y is 0, and our z is 1. And now I'm going to ask you to check it. So if I go back to my original problem and I do 2 times my x, which is 2, plus my y, plus my z, will I get 3? Yes. Let's check the second one. 3 times your x, which is 3, 2 times your 0, 0, minus your z, will that give you this number? Yes. Last one here, the negative of your x, so it'll be -1, plus 3 times your y, plus 2 times your z, does that give you this number? Yes. So it has to check for all 3, and so now we know that this is the correct ordered triple. All right, and this one, they're just asking us to write the equations. They're not asking us to solve them. You can solve them the way we just did that last problem. But we're just going to write the equations. So go through and read the problem just like we did all those story problems and figure out what it is that we're even talking about. So hopefully you've figured out that we're dealing with money. We're figuring out, or we're dealing with how many tickets. And then at the very end, they're doing some kind of a comparison. They're comparing one thing to another. So let's go ahead and deal with the money one. So we've got a few different money options in here. We have a $5, a $15, a $25, and then it says $3,940. So you have to recognize that that's your total. So over here, I'm going to put $3,940. And what we're talking about here are the tickets. It says a regular ticket costs $5. So that's going to be 5 times a regular. So 5 times X. And a premium ticket costs $15. So that's going to be $15 times each premium. And then an elite ticket costs $25. So then it's going to be 25 times the elite. So we've made up the equation dealing with money. So if we've already used all that money, please don't use it again. So the next thing we're talking about is how many tickets. Remember, X was regular. So do you know how many regular tickets were sold? If you don't know it, then we can't put a number in. We just have to leave it as our variable. And remember, our variable we used was X. Same thinking, we don't have a clue how many of the premium tickets were sold. So we're just going to leave that as Y. And the same thing with the elite. We have no idea how many, so leave it as a variable. But together means add them, we do know that there's a total of 440 tickets. Total goes after the equal sign. So now we're going to do a comparison. So now they're saying regular tickets are. Well, are is kind of plural for is. Regular tickets, regular was X. X is equal to 3 times, so 3 times the premium and elite combined. And if you combine tickets, you're adding them together. So the premium and the elite combined. So that's how we would set up our system. I did not ask you to solve this, I just want you to set it up. So by now you should be able to check an ordered triple to see if it works for a system of 3 equations by plugging them in and seeing if they actually equal the number on the other side of the equal sign. You will know how to write a system, and then you also know how to solve a system.